Okay, in this lesson, we're going to start to work with angles, and we're going to start by looking at what the graphs. We're going to graph some in the coordinate plane, and an angle in the coordinate plane is in what's called standard form. When the vertex is at the origin, so there's your vertex at the origin, and one ray lies on the positive x-axis, right here, and we're going to rotate from there. The ray that is on the x-axis is called the initial side. Well, put it in the other blank. Initial side. The other ray, and because we're going to rotate from there, the other ray, which is right here, is called the terminal side. That's where it starts, or where it stops. It starts here and it stops here. Initial is your starting point. Terminal, root word terminate, or termin, is the root. So therefore, counterclockwise rotations results in, okay, if we're rotating in a counterclockwise rotation, that would be the positive angle measures. Clockwise rotation, if we're rotating here like a clock, that would be your negative angles. The most common unit of measure for the angle is called the degree, and we all remember and know the symbol for degree. A degree is equivalent to 1/360th of a full rotation. So here you see the degree measures. If you start here, that's a 0-degree angle. If you rotate from there, if you rotate to here, that'd be a 90-degree. Rotate to here, that's a 180. Rotate around to here, that's 270. And then one full rotation we know is 360 total degrees. So let's sketch each of these angles in a standard form with a given measurement. And these are not going to be exact, so we're just going to get as close as we can. We know, again, we're going to start here along the positive x-axis. Let me use a lighter color here. We're going to start along the positive x-axis and we're going to rotate. We know that here is a 90-degree angle. Halfway through would be half of 90, which is 45. So a 65 will be somewhere right along in here. Let's put an arrow for a ray there. 320. Again, we always start with the positive x-axis. This is 90, 180, 270 if we rotate around to there. If we rotate it all the way around, we're at 360. So it's going to be nearly halfway here. And I like to draw like a little arrow showing that we started here, we rotated in this direction, and 320 would be right around in there. 415. Now we know one full rotation is 360, so we've rotated beyond a full rotation. Let's see how far we rotated beyond a full rotation, and you can do that by taking away 360. So we've got to go 360 plus 55 more. So we're going to start here. Again, our initial side is always at the x-axis, positive x-axis. We're going to rotate one full rotation, and then we're going to rotate another 55 degrees beyond that. So that'd be about right there. So let's draw this circle showing how we rotated. We went one full rotation and then another 55 degrees beyond that. Okay, the next one says a negative 140 degrees. So we're going in the negative direction. So again, we always start with the positive x-axis. Again, this would be 90 degrees. If we went to here, this is 180 over to here. So we're going to rotate 40 degrees short of 180, so about right there. So negative, that would be 90, and then 50 more would be negative 140. Negative 15, again, we're going in the negative direction, so 15 degrees, that's going to be 1/6 of 90, so not very far. So we're going to start with our positive x-axis and rotate about that far. Negative 210, again, start with your positive x-axis. This is 90, 180. So we're going to go a little bit beyond 180, so about right here. That'd be negative 90, negative 180, and then 30 degrees more would be negative 210. Okay, next up we're going to measure angles in a little bit of a different way. We're going to measure them with what's called a radian. And you see here an example of about how big a radian measure is right there. And let's just read the definition. A radian is a unit of angle measure based on arc length. 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. Recall that the circumference of a circle is 2 pi r. So what we've done here is we've taken a radius, the distance from here to here or the distance from here to here, and we've wrapped it. We wrapped it around the circle. And the arc length there, the length of that arc, the angle that intercepts that arc length there of 1 radius, we're going to call this angle measure a 1 radian angle measure. Here is how big a radian is. 360 degrees is equal to 2 pi radians. If you were to start here and go all the way around, the angle measure formed by that, well, actually, the angle measure here formed by that would be 2 pi radians, 360 degrees. 180 degrees is equal to pi. Since 2 pi is 360, then 1 pi would be half of that, would be 180. Here's how we convert from degrees to radians, because we're going to be working with both. To a radian measure is equal to a degree measure times, this is called a conversion factor. We're going to take our degree measure and multiply it simply by pi over 180. That's it. And I'm going to put my degree symbol there. And then to convert from radians to degrees, we're going to multiply by the flip-flop. So there's our chart of how to change from one to the other. Now let's actually show you what we mean by that. Convert each angle measure to radians. So 60 degrees. To convert a degree measure to a radian measure, we multiply by pi radians over 180 degrees. Now here's how I remember that. Is when you multiply by that, let me change colors here. When you multiply by that, the degree measure on top and the degree measure on bottom cancel. And that's what you need to do, because we need it to cancel out the degree measure, so we're left with only a radian measure. Then we're going to reduce. 60 and 180 can reduce. Divide each by 60 gives you a 1 and a 3. Multiply the tops, multiply the bottoms, and you're done. Now we want to leave these as exact as possible, so let's leave the top as 1 times pi, which is pi. Let's do the bottom as 1 times 3, which is 3. So pi over 3 radians, and that's going to be exact. We'll talk about in a second. That would be very easy to convert back the other way. Well, we can go ahead and talk about it now. This is 180 degrees. Pi, I said, was 180. If you were to take 180 and divide it by 3, yeah, that gives you 60. Okay, 160, the next one. Let me zoom in a little bit more. Let's do 160 over 1. We're going to multiply it by pi radians over 180 degrees. The degree measures cancel each other out. We're going to reduce. We'll divide top and bottom by maybe 20. That leaves you with an 8 and a 9. So on top you have an 8 and a pi. On the bottom you have a 1 times 9, which is 9. And now that is in radians. If you want to check your answer, you can always plug in 180 here. You can do 180 divided by 9, which is 20, and then multiply that by 8, and you do get 160. 330, change to radian measure. We're going to multiply by pi radians over 180 degrees. Now let's talk about why this is even legal. Pi radians is the same thing as 180. So pi divided by 180 is going to be 1. So you're simply multiplying by 1. That's the reason that this is legal. Degrees cancel and leaves you with just radian measures. Let's reduce, and you can always reduce twice if you can't think of something that'll divide into both of these. I know that 6 will, and that will leave you with a 55 and a 30. And then 5 will divide into that. That leaves you with 11 and a 6, and you're done. So on top you have an 11 pi. On bottom you have 6. And now that is in radian measures. Again, you can always check this by taking 180 and divide it by 6. That's 30, and multiply that by 11, and that gives you 330. Number 10, negative 45 over 1. Multiply by pi over 180. The degree measures cancel. Go ahead and leave your negative. 45 and 180 we can reduce by 5. That leaves you with a 9 and a 36. You can reduce it again by 9. That leaves you with a 1 and a 4. So we're left with the negative, which I've already written down, the pi on top, the 4 on bottom, and that is in radians. And if you were to do pi divided by 4, that does give you 180 divided by 4, which is 45. Negative 230, we're going to multiply it by, again, pi radians over 180 degrees, because they're the same thing. Degrees cancel, Go ahead and write down your negative before we forget it here. 230, first off, we can very easily divide by 10 by just marking out the 0, and I think that's all you can divide. So you got 23 pi on top, 18 on bottom, and again, that is in radian measures then. Negative 75 degrees, multiply it by pi radians over 180 degrees. The degree measures cancel each other out. The top and bottom are both divisible by 5. That leaves you with a 15 and a 36. We can then divide it by 3. That's a 5 and a 12. So you have a negative 5 pi on top, a 12 on bottom, and that is now in radians. Again, you can always divide 180 divided by 12 and multiply by 5. 15 times 5 does give you negative 75. Done. Okay, next up, let's convert some radians to degree measures. Starting with number 13, converting radians to degrees. Now, there's two different methods of doing this. The method that they tell us is now, since this is in radians, you can think of it as radians up here, we're going to multiply by 180 degrees over pi radians. The reason we're going to do that is because radians would then cancel with radians and would leave you with degrees. There is going to be an easier way here we'll talk about in just a second. Pi cancels with pi. 18 cancels to 180 and leaves you with a 10 and a 1. So on top you have 5 times 18, which is 90. Let's see, a 90 degrees. Is that all that's left? Oh, no, that should have been a 10 right there. I knew that was wrong. A 5 times 10, which is 50 degrees. And that is all that's left, 5 times 10, so you're left with 50 degrees. Now, much, much easier way of doing this. And we'll work at each of them both ways to begin with, just to show you. When you're wanting to change from radians to degrees, take out the pi, plug in 180 degrees. Now you have 5 times 180 divided by 18. I like to divide first. 180 divided by 18 is 10, and you have simply 5 times 10 now, which is 50. Next one to to change from radians, because this is in radians, to change from radians to degrees, we're going to multiply by 180 degrees over pi radians, so that our radians cancel. Pi's also cancel. 9 and 180 leaves you with a 1 and a 20. On top you have 11 and a 20, which is 220, and you're left with your degree symbol, so 220 degrees. Number 15. Oh, and by the way, you could have just started with, much easier, scribble this out, put in 180 degrees, do 180 divided by 9, which is 20, so this is 11 times 20, same answer. And let's just do this one that way. Let's mark this out, plug in 180 degrees, so you have 7 times 180 divided by 3. Let's do 180 divided by 3 first, then you're left with 7 times 60, which is 420 degrees. Number 16. See again how easy this is. Plug in 180, leave the negative. 180 divided by 6 is 30 degrees. So pi over 6 is a negative 30 degrees. 17, I'll do it the other way one more time just to show you. Since this is in radians, I wish they would put the abbreviation there. We're going to multiply 180 by 180 over pi, because again, 180 and pi is the same thing. Radians cancel, pi's cancel. 12 and 180 cancels, leaves you with 1 and a 15. So on top, you're left with a 19, a 15, and your degree symbol and the negative. So negative 19 times 15, I don't really need a fraction bar anymore, gives you 285. When you multiply 19 and 15, you're left with your degree symbol, so negative 285 degrees. Okay, number 18, the last one of these, negative 3 pi over 4. Again, I want you to get into a habit of just putting in 180 for the pi, because pi is 180. Reduce. I always like to reduce first or divide first. That would give you a 45 and a 1, so it reduces completely. So now you have 3 times 45, which is negative 135, and that's in degrees now. Next up, we're going to be talking about coterminal angles. Now let me scroll over here and show you what a coterminal angle is. If you look at the word coterminal, co means with or together. Terminal, we've already talked about what the terminal side was. That's the side where it stops. So if you have two angles, like notice this 90-degree angle right here. This 90-degree angle is actually the exact same thing as a negative 270-degree angle. They have the same terminal side. So therefore, remember, co actually means with or together. Two angles that have the same terminal side, or they stop at the same place, are called coterminal angles. So what you can do is you can either graph these. That's one method, but the easiest way is if two things have the same terminal side. Okay, take this 90. Okay, and now take maybe 360 from it. That means you're coming here and then you're taking away 360. You're going to end up back here. Or if you add 360, you're going to end up back where you started. If you take an angle and you add a rotation to it, or you can add another one, or you can add another one, you're going to end up in the same place. Or if you take away 360 and take away another 360, take away another 360, you end up in the same place. So the way that you deal with coterminal angles is you either add or subtract rotations. And that's going to be the easiest method to do that. So, so angles in standard position with the same terminal side are called coterminal angles. Determine whether the following angles are coterminal. Again, all we have to do, let's take our first angle, let's take a rotation away from it, and see what we get. 305 minus 360 gives you a negative 55 degrees. So that is this other angle. So they are simply the same angle with an extra rotation added. So yes, these are coterminal angles. Next up, take 330 and either add or subtract a rotation. Or take negative 170, and you could do it this way. You could add a rotation to negative 170, and that gives me positive 190. Well, wait a minute. Let's think about that. 30 is over here. Positive 190 is down here somewhere. So no, these two angles are not coterminal. These are the terminal sides. Starting here, here would be 30. Starting here, here would be 190. So therefore, these two angles are not the same. Or you could say negative 170 if you instead of positive 190. And you can see those obviously are not the same. Number 21. Pi over 4 and 9 pi over 4. Now, let me share something with you. As soon as I see radian measures, again, radian measures sometimes are a little bit confusing. So what I do automatically is I change them to degree measures. So this would be 180 divided by 4. That's a 45-degree angle. 9 pi divided by 4. Pi divided by 4, reduce that. That'd be 180 divided by 4, which is 45. 9 times 45 is a negative 135. So I'm dealing with 45 and negative 135. And let's see if those are coterminal. 45 is up here. Negative 135 starts here, and we're going to rotate negative 90, negative 45, another 45. There's negative 135. Here's the other one coterminal, or excuse me, one terminal side. Here's the other terminal side. These are not coterminal because they do not have the same terminal side. Or pretty much another way of looking at it, their graphs aren't the same. Number 22, 3 pi over 2. Pi over 2 is 180 divided by 2, which is 90. 3 90s is 270 degrees. Pi over 2 again is 90. This is negative 5 times 90, which is 450 degrees. Again, the easiest way of doing this, let's add a rotation to this. Pretty much to give me something between 0 and 360 to graph, and I get negative 90. So is 270 and negative 90 the same? You could add another rotation. If you added another rotation to that negative 90, you get 270. They are the same angle. And again, the reason why is if you were to graph negative 90, you start here and it comes to here. That's negative 90 here. If you were to graph 270, that's 90, 180, 270 is the exact same terminal side. Okay, next one says give two coterminal angles for each angle, one positive and one negative. And again, all we have to do to find coterminal angles is add 360, subtract 360. So if we took, let's see, what are we doing? Two coterminal, one positive, one negative. So if we add 360, we get 510 degrees. There's one positive. If we subtract a rotation, it gives us negative 210 degrees. So there's us 2. Positive 510, negative 2, or positive 510, negative 210. Take 265, add 360, gives you 625 degrees. Subtract 360, gives you a negative 95 degrees. There's a negative and a positive coterminal angle. Number 25, take negative 25, add a rotation. So add 360 gives you 335. Take that same angle, subtract 360 gives you negative 385. And you could graph actually all three of those angles, and again, they would have the same terminal side. Number 26. Again, pi over 12. Now, we can do this a little bit different. We could change them to degrees, but we want our answers to be in radians here. So what we're going to do, we're going to add a rotation. And again, instead of adding 360, remember that our rotation is 2 pi, which is the same thing as 360. So we're going to add 2 pi. The way we're going to do that, we're going to find a common denominator, multiply top and bottom by 12. Gives me a 12 on the bottom and a 24 on top. Now we can add that rotation. 1 pi plus 24 pi gives me 25 pi over 12. And then we can subtract a rotation. 1 pi over 12 minus 24 pi over 12 gives me, I'll write it down here, negative 23 pi over 12. So there's our two coterminal angles. Number 27, again, we're adding a rotation, which is 360, which is 2 pi. Multiply top and bottom by 6 gives me a 6 on the bottom and a 12 on top. 7 plus 12 gives you, I'm going to write it over here, 19 pi over 6. When we subtract the rotation, I'll write it down here, 7 minus 12 is a negative 5 pi over 6. So we have a negative and we have a positive coterminal angle there. 28. Add 360 degrees, which is 2 pi, 2 180s. Multiply top and bottom by 18 gives me an 18 on bottom and a 36 on top. Negative 11 plus 36 gives me a 25 pi over 18. And then when I subtract it, I'll get a negative there. Now, sometimes you might have to add 2 rotations or add 3 rotations to get a positive. And same thing with subtracting. Negative 11 minus 36 is a negative 47 pi over 18. So you have a negative and you have a positive there.